So happy to represent Ku here, and we are a new kid in the block from a Aerospike community. It's just been 6 to 8 months that we are fully on Aerospike. But there's a lot of background I want to share about the kind of scale that we are in, the kind of use cases we are dealing with. And I personally feel after the few interactions here and the talk from Srini that we can definitely expand a lot of our use cases into a more bigger database, which is Aerospike. And just to give a simple understanding of some of the use cases, what Ku stand for, there are a few tenets with which Ku as a platform is being developed, right? Because we started off as an experiment, and the way the system grew, we ourselves had to ensure how do we prepare for scale. As soon as the scale is actually going on, how do we look at different data stores, what kind of systems to be put in place. So there is a lot of things going on which I would like to share, and also deal with the Aerospike system. So, what I'm going to cover in this presentation is some of the important use cases, the core architecture. We'll deep dive into one of the important features of Ku, which is the feed ranking that it's quite common in any of the social platforms, be it LinkedIn, Facebook, Twitter, Insta. As soon as you open the app, you see the feed, right? So how Aerospike is being used here. We'll also see how it was done earlier, even though it was just a 1.5, 2 year Ku as a company. There's a lot of learnings that we have had from the time we did versus how we moved into Aerospike and why we chose Aerospike. So we'll go a bit deep into the architecture and a few impact as well as next steps. All right, so I'm just going to spend a minute here about what Ku is trying to solve here, right? So the left side of the screen is pretty straightforward. You might have heard it in a lot of places. So the most important thing for us is scale, because as Ku is going to become big, right? So we are at a place where we can actually look at almost 500 million internet users immediately within the next 1 year, and also look at expanding to global. So for ourselves to be prepared for that kind of really rapid scale, we need to really invest in our platforms. We need to be looking forward, not just in moving rapidly from our current user base to 500, 600 million user base, but also in a very short period of time. So the architecture with which we want to set up, or the way in which we want to set up our core backend systems, we put in a lot of thought there. And we are looking at some systems which are very battle-tested, well positioned for these kind of growth. And to achieve these things, what is Ku doing, right? So if you look at the social app side of the things in India, a lot of Indians are using Facebook, we use LinkedIn, we use Twitter, and Twitter is exclusively in, let's say, in some pockets of the English-speaking crowd. But the majority of the other crowd, right, they are still stepping into the thoughts and opinions platform, where people across tier 2, 3, 4 cities, they are coming into the microblogging world, but still not fully sure as to what this is about, how to participate, what are the things to keep in mind, etc. So we need to build in India some of these social apps for these users who are relatively new in the space. And of course, we all know India is a language. There are multiple languages spoken. Currently, a lot of our efforts goes into ensuring the translation as well as the transliterations that happen. Of course, we use some of the readily made translation APIs that are there. But if you think about it, every content that gets created on Ku, we need to store as cache across the different dimensions of the languages. And I'll go a bit more into the detail. That becomes a bit more challenging and complex. Then in terms of the product experience, if you are from different parts of India, different parts of the city, you need to have a different experience altogether. So we create in our own thing called micro worlds. So if you are in Lucknow, you open Ku, versus if you open in Bangalore, if you open in Chennai, if you open in some other city, the kind of people you see to follow, the kind of people who are putting the content, the local community that is there, that gets a boost. So there's a lot of work that happens in terms of these micro worlds, and that again is an architecture thing that we work on. Then at the end of the day, any social app looks for attention from users, right? Because the user has 10 minutes of his time, he wants to look for some specific information, or it could be just casual browsing at times. So during that attention, when he's on our app, how do we give him the, how do we ensure that the discovery happens to browse new content, and at the same time, am I able to personalize and give him the best topics? That's also a very critical thing in our architecture. We understand the content of anything that comes into a system through something called NER. It's more of an ML thing that happens there. I'll go a bit more deep into that. And finally, there is a lot of algorithms that happen to match the right creators who create content versus the people who want to consume that content. So that also happens in real time to a large extent. So we'll go deep into that. So I'm going to talk about these two highlighted ones, the feed ranking and the fan out that happens in any social tech. Just to give an idea about some important use cases where, though we are not leveraging Aerospike for the non-highlighted ones, there's a lot of things that can happen as we move forward. So as soon as the content gets created in Ku, right, we need to understand what this, in what language it is coming, number one. Right? As soon as we understand that, okay, this is from Kannada, this is from Hindi, this is from so on and so forth, we go through a small topic enrichment exercise to figure out what is the noun, what is the subject, what is the predicate, and kind of label that content, right? Now you can imagine if this content is coming from, let's say, Tamil, and I need to label it, the machine learning systems will give you that model to translate and create those specific labels. Now we need to ensure that that data is actually stored and labeled against that particular Ku or the content. So like that, for every Ku that gets created, there's a lot of metadata that we create at real runtime, which is very critical in doing the matching piece, right? We do a lot of content now is becoming more images and video. So there's a lot of in-depth understanding that we need to do about what this image is speaking about. On the image itself, there are a lot of memes with a lot of text. We need to understand that. And in some cases, the first 5 seconds of the video is very critical for the full experience. We need to understand that as well. So we kind of put a lot of analytics as soon as the content gets created so that we are able to label that again. Text classification is very, it's become more of a standard procedure now. It's similar to labeling it, but what happens here is we also, even though there might not be some important people on our platform, let's say someone from Bollywood, someone from politics, someone from sports, but there's a lot of information being talked about these people, right? So that becomes a part of our recommendation system as well. So if someone is looking for what is the latest that is happening in MS Dhoni's life, right? There's a lot of content other people have created about MS Dhoni. That's something that we try to show. That's how text classification happens there. Feed ranking is, I'll go a bit more in depth, but just a one-liner is how do we personalize the feed that comes to your app in sub-millisecond latency? And that's what we try to achieve there. Fan out is something where if you look at any social app, right, you take any of your important celebrities or your professional or anyone for that matter, right, who is a pretty eminent or very well-known in the social space. They have millions of followers. So whenever they put a content on the platform, that content needs to be sent to at least all their followers. That goes into millions. How do we achieve that? That's a classical fan-out problem that happens in any social system. So that's something that we have tried to solve the best of our ability. We'll walk through that. Notification system is also quite critical in a social system. We need to figure out when to send notification. How do we bring the churn user up? How do we ensure that we don't send too many notifications, but also send the notifications that are very critical? I have put a content on Ku. A lot of people are liking that, so I need to be updated. Some new celebrity has joined. He has put some content. I might be interested in understanding that. Or some people have started following me. I need to understand that. So a lot of experiments happen in the notification system. It's a bit of human psychology also there to send the right notifications to the right people and at the right time. So there's a lot of experiments that actually go into our notification system to get it right. And finally, in any content system, spam comes as a byproduct, but we need to figure out how do we filter those spams, how do we filter it at the right time so that our overall content, it doesn't get abused. So these are the challenges we face, or in a way where we look at how do we solve these problems. So The right side of the slide is talking about these two, feed ranking and fan out. So what we tried doing is, we look at, I'll go to the next slide and come back to this. So if you look at the feed ranking, so this is the core architectural goals that we have. So the feed needs to be timeline. When I say timeline, I meant to say it's more chronological in nature, but we also need to give some kind of a personalized experience at times. So when we started, we went with a fully chronological timeline experience. But as we came to know that, okay, people are interested in a bit more personalized content which they might not have easily discovered or accessed, why don't we bump it up, right? For example, I might be a user, I might be using 2 or 3 times in a day, whereas there are some people who are using probably twice a week. So when these people who come on the system, they need to be shown the coups at the top of their content, which are more trending, which are more important to them, which have more affinity towards them. So that's why the critical thing is to give a combination of that. We also need to ensure there is good freshness in the feed, because as I said, there are people who are power users who come multiple times in a day. So I need to always ensure the right content comes on the top. There's a lot of math that goes beyond what content to show on top. Then it has to be relevant. To do the relevance, which is a kind of a personalization equivalent, we have a lot of scores for every content that gets created. So any content that comes, if it starts trending or there are a lot of likes, the rate at which new comments come, the rate at which the impressions go up on that particular content determine the relevance as well as the velocity with which we can call it as trending. So we look into that. Then there is a concept of first degree network. I follow someone and these are in my network, these are in my first degree network. But how do we ensure that the person whom I am following and also the person who is following them are connected into the feed, right? Because I would be interested in knowing some content among my followers, but if my followers are liking some content of people who are not in my network, I also need to be provided that particular information. That's how we look at the first degree network, the friends of friends and all that. And finally, we look at reactions. When a particular content gets liked, it gets re-queued, it gets shared, we know that there is a validation of this content. So that becomes a signal for us. So the architectural goals look at these important 5, 6 core metrics, and we figure out some kind of an SLA, and there is a careful balance with which we assign some weights so that we get the right feed in person. The thoughts that went into building these, right? We always wanted to ensure the popular ones are not missed by the users. That's very critical, because in the last 4-5 days, there was a lot of discussion about Bangalore weather, and there were a lot of interesting memes that came. And that was trending. For a social content network like us, it's important to show that discussion that's happening because it's real life, right? And in some cases, there's a lot of things about sports, about politics, so on and so forth. A lot of things happen. Anything that is getting trending, right, we don't want to miss out. So we always wanted to ensure the way we capture the trending coups, both in terms of impressions and reactions, are well captured. Then freshness, as I mentioned, was also important. The important thing that happens, though this part is not on Aerospike right now, we use a different graph data store. There are a lot of followership that happens in any social network, right? Now this is just to give an understanding of this. So Coup has got close to around 35 million users at this point of time. And the overall connections that get established among these 30 million is north of 700 million, right? And what we have also seen is as the network becomes dense, for every 5 million new users I'm going to add, the ratio doubles in terms of the connections. It's becoming more denser. So more people are getting interconnected. Right now, there are a lot of satellite networks, there are a lot of sparse networks. But once we are able to connect some big cohort of networks, this density becomes very big. So when this density becomes big, there's a lot more understanding of the user's connection, the friends of friends, etc., that we need to cater into our thoughts while doing the architecture. Then as a user, you are browsing, you are looking at your coup, you are reacting. All that is captured as impressions for us, which needs to be saved it can be later utilized, and it goes into few pipelines to make the algorithms better. So on one side, you have different peoples, different people who are coming from different segments and cohorts. These cohorts could be either I'll just pause here, I don't know. Okay. Okay, so the cohorts could be from various regions, languages. It could be people who are following different topics, and it could be of various other such activities. Then there'll also be, for a cold start problem in any social network, right? We always look at, okay, these are the people who came, but who are also similar to these people who are already in the network. So we look at that particular, we use collab filtering there. Then we have created our own set of scores or algorithms to understand what is the affinity score between a person and a creator. So what does that actually mean? If me as a person, if I'm liking a lot of posts from Virat Kohli who is on our platform, there is an affinity, right? If I'm skipping a lot of content from a specific user, my affinity is relatively low. So there's a lot of such scores that gets computed every time, and that score is also very critical in creating the rank or the sort order. And the content that gets created, right? The content is classified under various topics like news, media, images. It could be a meme. It could be talking about some specific thing that is happening in and around the city. So we classify that across around 30, 35 set of things. Then we also have media, which is about your images, video, etc. Then we also look at content similar to this content. So even though the other content is not created by a very good user, but he or she is also talking about this content which is trending. So we need to identify those content as well. So all this data is used to do our matching. So this is where Aerospike comes into picture to solve all these problems. So the left side is your read, the right side is your the write path. So if you see the data path, a coup gets created by a user. What we do is, there are two kinds of users. One is a normal user, and other one could be a very important, eminent person who has a lot of followers. So we call that as a VIP, right? As soon as a coup gets created, right, we have some thresholds where if I have more than 1 lakh followers, I fall under a VIP, as simple as that. At this point of time, we can improve that. So I'll tell you the reason why we do that, right? In Aerospike DB, right, all our keys are nothing but user IDs. So if I have 35 million users, I have 35 million keys, right? Against every 35 million keys, I have 1,000 feed items. That's how our database is structured at this point of time. So any user who's on coup who comes to the database, right, they'll be given that particular feed pre-computed list in a sub-millisecond latency time. So that's the way in which this gets updated. Now to update into this Aerospike system, there are a lot of other flows that are happening on the side, as you see. One is we do a lot of enrichment of the coup itself. We look at the kind of reactions that are happening because a coup can get liked, commented. The comment itself becomes a sub-coup. There's a lot of those things happen. And also we have a lot of other signals that come when the user is browsing. We have not accelerated on that piece, but that's also very critical in changing the feed in runtime, right? So if you look at all these different signals that we are capturing and putting it into our Aerospike, we see across some specific users, right? Let's say a very eminent politician or a person who has thousands or lakhs of followers. It doesn't make sense to fan out his particular content into all these users who are following, because less than 10% of the users who are eminent, almost 90% of the people follow them in a social network. That's the math. So we will be bombarding all the keys all the time with all the data. That's a fan out problem. So rather than that, what we have done is we have taken anyone who is less than 1 lakh users, we have put that in our Aerospike as a separate key. So what happens is when the lookup happens to create the feed, we first look at these people who are following them through our graph network. So this is where probably the graph model might come into picture. Right now for graph, we do a separate I/O to our Arango cluster and then come back to Aerospike. So if there is something that can be integrated within this, then it reduces one I/O call for us, which is very critical for us. So once the follow-ship happens, we understand that this person is following this ABC people, and we take the content from the Aerospike system and serve. And when the reactions are happening for any particular content as well, we try to, it's called counter updates, right? We are not looking at strong consistency there, but eventual consistency. It goes through a pipeline of message queues, etc. We use Kafka there to push data into Aerospike. And then finally, the enrichment is where it happens in batches, because as you know, ML models have a certain latency out there. It's not very, some of the ML models have a very good response time, but as we also scale our ML models to move into different languages, move into different types, there's a lot of latency that gets added. So even though the queue has got created at, let's say, 10 o'clock, by the time the ML enrichment happens, it could be 10:03, 10:04, etc. So we also need to ensure the time is very critical. And during that time, if we need to change the sort order, even though we have updated, it has to be re-updated again. So there's a lot of updates that also happen on the same feed that was created. So there's a lot of noise, a lot of updates against the keys of the Aerospike. So now what we have done in Aerospike also is we have made use of the two types of namespaces that are there, the memory as well as writing into the disk. So in some places where we need it to be stored in the disk, which is the main feed that gets created against the user, we have a better way of doing that over something like a system where it is more of a in-memory space. There are some advantages with that. And finally, when these users are able to read as soon as they open the app, there are different services that directly call our Aerospike system to get the data. So if you see the, I'm just trying to give you an idea of how it looks on the product so that you can relate to that. So the first is more of a simple feed that you see as you scroll. On our feed, we show that technology follow topic, right? So that gets enriched from our topic pipeline. Even that technology as a word is stored in Aerospike. It comes in real time for the user when they scroll, right? I am following Shubham Pai, but I'm not following Muthu Kumaran, right? But Muthu Kumaran liked Shubham Pai's coup. Sorry, my bad. I am following Muthu Kumaran, but I'm not following Shubham Pai. Muthu Kumaran is in my first degree network, so he liked the coup, right, of Shubham Pai. So that's why Shubham Pai's coup came in my feed, right? That is also almost done in real time. It's called out-of-network coups. Out-of-network coups are very critical when you want to expand the content to a wide variety of users. And finally, fourth is where you see all the reactions against a coup. So this has got some 21, 21, whatever, some number is there, right? So to create this feed with all these different information topography here in real time is what we have tried to achieve so far. So the important things in the old architecture, right? So since it was something that we have started the work, right? There's a lot of things to learn, experiment, see what works well for the users. The experimentation framework we earlier had, whatever we wanted to do, right, on the older technology, it was a limitation for us. We could not quickly do things because there were always constraints about our old architecture. So with Aerospike, we are able to do that quite easily because there are a lot of advantages with which we have architected our database objects and sets, and the amount of caching, secondary feed, primary feed, the way in which we have done. So it has given us that flexibility. The second is there are a lot of times when the user's feed is not created, or he might be a user who is inactive, but now he has come after 10 days. So for us to compute the feed during the time he has come and also ensure it works well, there's a lot of pressure on the application servers. So we try to again ensure that is minimized by making use of Aerospike in some cases. And if you see the three profiles I've just said, so 2.3 million followers, 1 million follower, or half a quarter million followers. If let's say all these three guys put a coup at the same time within 5 minutes, they will literally bombard all the users of coup on the platform. So that's the fan out problem I'm talking about, right? So that's how we try to address the fan out issue. So just moving on to a separate slide, this is just more like a mind map for us to understand on the people how we look at, and on the topics of interest, segment, meta, and similar people. So the people, our people segment itself has these different signals which are critical in ensuring how the feed happens. So why we chose Aerospike and what's the impact? Obviously, I don't have to sell it here. There's a lot of good architecture with which this has been built. I'll concentrate a bit on the right side. See, one of the things in any social network we all measure, right, is as a creator, right, if I come on the platform, if I'm not getting user love, I just move out, right? So reactions is the social currency. So for us as a product or a platform, the reactions really determine how healthy the system is. And the creator thrives for this particular dopamine hit at a lot of time. So if these particular reaction percentage drop for a creator, he will definitely churn. So we really monitor that reaction metrics very closely, and that we were able to increase by more than 10% when we moved to this new architecture, along with other things that we did. The affinity score improved. So what this basically means is, if some set of coups did not come in my feed, I would have never got a chance to even react to that person, even though I might be an active user, right? So we were able to surface more relevant content to the users in his feed, so that they're able to see that person, see that content, and actually able to react. So reactions improved, which improved my affinity score with that person. Once my affinity score improves, that becomes a very strong signal for my personalization system. Then improvement in impression metrics. Impression metrics are, even though I have not reacted, I have viewed it. I've spent at least 2 seconds. I've gone to the details. I've opened the image. I have spent the video watching at least for 5 seconds. So these are all the impression metrics that we capture. By doing all these things, we were able to improve the retention metrics, and also to time to market some of our new algorithms was very easy. And I spoke about efficiency in handling our fan out. So the way we calculated this was 5 or 6 important VIPs could at the same time. How much time did it take to update in all the feed? So as simple as that. So we looked at that metric and saw Aerospike performed really well. So I'll just cover this since there's 3 minutes more here. So as any architecture that needs to be done right, whether it is Aerospike or any other system for that matter, we need to understand our use cases really well. Only then we'll be able to get the full juice out of the system, correct? That goes without saying. So what we looked at is, what are the different use cases we want to put in Aerospike? What we should not put in Aerospike? There is a very clear document in our technical architecture. That we started with that. And we also have a discussion as to why we don't want to put in Aerospike, why we need to put in Aerospike. There's a lot of discussions that happen on that. That's how we look at things. Now in the beginning, we were all new, the team was formed new, so we didn't want to be too ambitious. We just wanted to say, okay, let's get the simple feed architecture right. Let's keep graph for a graph data store, let's keep cache for the cache data store. So we went with that separation. And it is giving us dividends. So probably in the next cycle, we might kind of combine few things. We had a very clear view of what are the number of keys, what are the objects, what are the object size, then what kind of compressions we need. We also looked at, it's a microblogging text, right? We don't have more than 500 characters, sorry, for 500 text length in any of the coup. But we also need to consider other metadata, the topic enrichment data, the language data, and all that. So we have to kind of look at what kind of max object size our system could hold, and also the compression type. and also what kind of replication factor we are comfortable with our existing architecture. So by looking at these things and by running some on our dev testing or the performance testing, we kind of optimized some of these write block size and post write queues to get the right latency that are needed. So this is something that I would recommend as an overall practice when you guys are designing the system. So what are the next steps for Koo, and what are some potential use cases? I just put this slide last night. So as we are scaling, DR becomes very critical. So we are working with the teams to ensure we follow the best practices. Of course, a lot of us who come from the Redis world, we have done a lot of Lua scripts, which is very irritating at times. So how do we get out of that? But we still want to get access to the low-level data structures, right, in your code. How do we do that? So I think there's APIs that are now available we can make use of. So also the data, multiple teams create a lot of data, multiple teams consume data. How do we ensure all this data gets combined, right? I heard some of the connectors that are being built, so it's kind of prudent for us to invest in that as well. And what we are also looking at is we want to look at knowledge graphs, right? Because social networks thrive on knowledge graphs. How do we ensure there's a very strong understanding of what our users are, and at the same time how they're actually building on top of it? So that's it from me. Thanks.
How do you manage all this, keeping low latency and real-time issues?
Yeah, the question is, in this kind of a system, there will be a lot of relational data. How do we manage low latency? So, simple answer to that is, we failed, we improved. There's no other magic to that. So, just to give you one example, right? The follow-followership network. You might think it's very simple, but it's not very simple. The way in which we are storing that follow-followership data in our database, we are using Postgres. Postgres is very good for wide column array. So we are storing all the arrays in an array table. I follow 1,000 people, 1, 2, all these user IDs. That gave us some flexibility till some point. It gave us good acceleration to develop that feature. But soon we realized, okay, we have hit the limit, right? So you move out of that use case. You invest in graph. Now, the thought process there is, am I benchmarking my SLAs, my services correctly? What is the scale at which this can go vertically or horizontally? And am I investing enough tech bandwidth to rewrite that? So that's been the thought process in the last 1 year. And we have rewritten many of our APIs that way. So as I said, we test, fail, move forward.
Thank you.
Question there.
Am I audible?
We can hear you.
Hello.
Yeah.
So I'm just curious, like, how did Koo solve the chicken and problem of networking in its initial days? So when there are no users, right? So how did you go from there to?
Yeah. So the question is, how did the initial network get built? So, so if I have to kind of spend some 3-4 minutes, 2-3 minutes there. So when we started Koo in the beginning, right, we looked at what is that is missing in the social network in India. That's the first question. Second question is, why none of the Indian companies are investing in building a social network? What is the problem, right? because we use LinkedIn, we use Google, we use Facebook, we use Twitter, but why no companies in India are building a people-centric network? These were the two questions. Now, if I have to ask anyone in this room, right, why, right? The answer is, to build a social network, you have to have a slightly different thought process, which is, I would say, away from your normal transaction system. You cannot go with your transaction platform mindset. So I come from Redbus. I was dealing with bus tickets, right? So Aprameya, Mayank, they came from Taxi for sure. Mayank also from Redbus. So we all are transaction based. So we had to unlearn a lot, right? So the second piece was the people who are in India. When we looked at the demographics of Twitter as one platform, we saw, though the number of users in Twitter, the MDAU, monetizable DAU is what they call, is close to 220 million as of today. The Indian users, what they report is just 23 million, and that was not growing, just 10% of it. So there was a story there. That's the metric, data metric. So we understood why that particular metric has not grown with the velocity with which a lot of other things have grown. The answer to that was the product for a normal Indian, tier 2, 3, 4 city, was very overwhelming if you give that product to them. It was not easily understood what they have to do. You can call it as a social xenophobia, where you enter the system, you don't see the people similar to you. You don't relate with the people who are there. And the kind of follow suggestions that come, you can't even correlate with that. So we felt that there is a story to tell here, and that's how we started. Now to accelerate on that vision, we first started in one language, which is Kannada, right? We went to Mandya, Hassan, worked with some specific journalists, people, etc., to get the content running, to get that initial critical mass. And then we expanded to Hindi. So even if you look at it, if you look at the first 5,000 users on our platform, they were all creators. There were no users. Creators liked other creators. That gave them that stickiness. Now we onboarded more creators and then the users. So we never went with, though we knew that users build the mass, for you to build a good network in the beginning, the creators should feel they get some gratification. They get that dopamine hit. Only then the creators stick. So we concentrated on creators and then build the mass. So that's been our journey. I hope I answered. Yeah.
So my question is that when you opt the Aerospike system, what major challenges you face in studying this?
Yeah. So my colleague Kalpesh is there. So you can talk to him when during the break, but I'll just briefly say in a minute. So I think we as a engineering team knew what the current problem we wanted to solve, which is to move out of some old legacy systems. I think the challenge, I would not say challenge, but the thing was, how do we build a system very quickly in-house? Like for us, time was very critical. So we reduced the scope of what we need to put in Aerospike, what I mentioned to you, right? So the challenge was to ensure what can be 100% sure by putting what use cases can I port it. To ensure that this happens correctly is one important part. The second part was, it was a matter of learning for us, because when we first put the architecture out, our application layer code, right? We use a reactive web flux, right? So similar to Node.js built on Spring Boot and Java. There are a lot of fire and forget queries that happen. So the problem with that approach also is you miss some of the updates going into Aerospike. We wanted to ensure that there is a good compatibility between our application layer code as well as our data store, because we can't suddenly change our entire application layer code. And where do we introduce message queues? How do we not? There was a lot of other things around the core Aerospike system that we had to consider before saying, okay, let's go with Aerospike. Yeah. I don't know whether we have time. We have run out of time.
So the spam metering in
Yeah.
Go happens, right? So is that like, does that happen pre-read or like a pre-write? would
So yeah, it happens in both the places. One is we have a rule set which gets filtered, it doesn't even get entered. In a lot of places, there's a policy as per the government where we need to store even though it's spam, so that in case it is something bad, we are able to report to it to the government, right? So what we intelligently do is, if it is something very bad, nefarious, we don't even put it into our store, it goes into a separate pipeline. But in some cases, let's say for whatever reason our systems did not catch them and it entered, we now track the impressions. If any particular content is getting a lot of impressions, after certain cutoff, it goes to a more hardened queue where the SLAs are more relaxed. There we catch them. I think good.
One last question there. Is there a question? Yeah. Another question
Yeah.
at the back. Maybe we'll take the last one.
On a lighter note, how many bots does Ku have?
Yeah, I'll give you a good answer for that. So what we have introduced is, we have introduced a feature where you can verify yourself. So I hope that answers the question. Yeah. Cool.